Hello and welcome to a lecture on K-nearest neighbor algorithm. I am Dr. Neelam Chaplot, working with Purnima College of Engineering. In this lecture, the contents which we are going to cover are what is K-nearest neighbor algorithm, example of KNN, distance measured use, numerical on KNN, and advantages and disadvantages of KNN. So what is KNN? K-nearest neighbor algorithm is basically a supervised learning algorithm that classifies the data points on the nearest training example provided in the feature space. It is an instance-based learning algorithm where computation for prediction of data is delayed until the classification. That's why it is also called a lazy learning algorithm. KNN is fundamentally the simplest algorithm and can be implemented easily. No model is created for classifying the data in this algorithm. To understand KNN, let's take a look at simplified version of a diabetic dataset, generally used for prediction of diabetic and non-diabetic persons in the world. We want to train the system using KNN to automatically classify the new person as diabetic or non-diabetic in this example. Here we are assuming only two features, blood pressure and glucose level, to identify whether the person will be diabetic or non-diabetic. The diagram is a two-dimensional graphical indication of diabetic and non-diabetic person present in the training set. Here, the green dots represent non-diabetic person and red dots represent diabetic person. Now we want to perform prediction for a new person which is defined as a black dot. Assuming the value of k in k-nearest algorithm as 5, let us see that the circle is drawn around the new record. In this circle, we will see that out of 5 nearest neighbors, 3 neighbors are diabetic and 2 are non-diabetic. Based on majority voting algorithm, the prediction is done that the person represented by the black dot is a diabetic person. Requires the calculation to be done to identify the distance between the training and the test data. So let us look at the distance calculation for continuous variable. One of the methods to calculate distance is Minkowski's distance. In this method, to find the difference between the training set T and the test set P, we will be finding the qth root of the absolute values of the difference between training attribute and the test attribute. Assuming that T1, T2, Tn are the attributes for test set and P1, P2 and Pn are the attributes for the training set. Qth value defined in Minkowski's distance is a user defined value. If we put Q as 2, the distance becomes Euclidean distance. And if we put Q as 1, then the distance becomes Manhattan distance. Distance calculation for categorical variables can be done using Hamming distance calculation. In Hamming distance between training and test data, we try to find distance between each and every attribute of training data with test data and finding the absolute values of those. In this example, when the value of the attributes of training data is equal to the value of the attribute of test data, then distance between Ti and Pi is considered as 1, else it is considered as 0. Let us understand it by an example. We have a training set T with attribute values 1, 0, 1 and test set P with attribute values 1, 1, 1. To find the distance between T and P, the first attribute of T and first attribute of P will be giving a value 1 because both attributes have same values. The second attribute of T and the second attribute of P will be giving a value 0, and the third attribute of T and the third attribute of P will be giving a value 1. Hence the Hamming distance between these two values will be 2. Let us see a numerical examples of k-nearest neighbor algorithm. In this example, we are taking 6 training records, and the new record, we have to identify whether the person is diabetic or non-diabetic for the test record, where value of glucose is 145 and value of blood pressure is 87. The distance measure we have to use is Euclidean distance, and the value of k is given as 3. In this example, you can see that the field diabetic is having a value 1 for the examples which are diabetic and 0 for the examples which are non-diabetic. Euclidean distance between each and every record of the training set is found with the test set. And these are the various values which you are getting. As the value of k is 3, we will be taking 3 nearest values from these results. The 3 nearest values is for first record it is 15.29, for third record it is 44.42 and for fifth record it is 47.67. Hence the nearest neighbor according to the calculations are record number 1, 3 and 5. Values of diabetic field for the 3 records is for first record label is 1, for third record label is 1 and for fifth record also label is 1. Hence by majority voting, the label of the test data predicted by k nearest neighbor algorithm is 1, that is patient is diabetic. So various steps performed for the algorithm of KNN are: first, we will initialize the value of k. We will load the training data. Then we will be inputting the test data to be predicted. For each record in the training set T, we will be calculating the distance between the test data P and the training record Ti using any distance matrix and store the differences in array called dist. After storing the value of various distances in dist, we will be sorting the elements in array dist in ascending order. Then first k entries from the sorted array are taken and the labels are retrieved. Assign the label of the test data as the label generated by applying majority vote on the k labels received. So what are the advantages of KNN? KNN is a simple to implement and use. It is non-parametric nature of algorithm, makes it very useful for various applications. The KNN algorithm don't require to tune parameters or make assumptions. It is a versatile algorithm as we can use it for classification as well as for regression. Disadvantages of KNN is the algorithm become computationally expensive with increase in the dimension of the data or increase in the size of the training set. That is, if we increase the number of attributes or if we increase the number of records, then algorithm is computationally expensive. The algorithm will suffer if class distribution is skewed. It means that if we are having classes and one class is having the majority records and another class is having few records, then the algorithm will be suffered. The accuracy of algorithm can degrade if dimension of data is very high, because then the difference between the nearest and the farthest neighbor will be very less. These are various references. Thanks.